Welcome to episode 2 of the Extract Data podcast. I'm John, your host, and my guest today is the head of data science at Zeit, Konstantin Lopukhin. We talk a lot about AI agents, how they impact the web scraping space, some of the issues they come up against, and how to effectively manage your agent when it comes to scraping data from the web. So let's get into it. I want to talk a bit about AI agents in this conversation and really understand where it fits into web scraping. But initially, what actually is the difference between, just talking to an LLM like we all know and love to actually having it in an agent and agentic form?
Yeah, that's a good question, because I think also I think the lines are starting to blur really, but I would say if you take the chat GPT, 1 year ago, or maybe like that, where you're just chatting with it, and then you would be basically talking to an LLM, and the LLM would produce some responses according to its knowledge, but it won't be connected to any external tools. It would be just, if it knows something, it says something. If it doesn't know, it would guess and hallucinate maybe. And so for software development, what you would do, you would maybe, paste it some piece of code you are unhappy about, or maybe tell it what kind of code you want it to write, and then it would try to maybe write this piece of code, and then you it won't test it, it will just try to guess, and then you can then try to test it yourself and see if it works. If it doesn't work, you paste the error. So you're you are the agent here, and you are using LLM for a bit of extra help and knowledge. And I think when we think about the agent, we think that there is actually someone else but you driving this process. So the agent would be some little bit of software, which can be pretty simple in terms of it's maybe some loop which calls LLM, and then an LLM can tell, hey, actually I want to run this piece of code and see if it passes the tests. And then this piece of code would invoke the required commands, and then LLM would receive a result of running this command. And through that, as a human, it's really hard to write any non-trivial piece of code which would work on the first try. If it works on the first try, you think, okay, something must be wrong, my test must not be running. And LLMs are much better at humans at one-shotting the code, but still they're not perfect. And so basically, if you equip LLM with ability to invoke some tools and to run the code maybe, or invoke other tools if we're thinking about non-coding context, then you get an agent. And also just acting in the real world. So for example, hypothetically, let's say you need to book, I don't know, I was buying a new bike recently, and my first road bike, and so I had to do a ton of research into figure out, okay, what kind of equipment do I need, and what kind of how it all fits together, and so on. And so in an ideal world, an agent would maybe be able to figure out, okay, based on what I need and how much money I'm willing to spend, figure out, okay, what are the little bits and pieces you need to buy, and look for them, look for good prices, look maybe for a single place where you can get them. And so in this case, you would the agent would basically do some work for you. Again, so this is expanding, using LLM as a thing which knows what it's doing and has some knowledge, and letting it act in the real world.
So it's that ability to carry out tasks for you that really separates it out. Is it able to, do the agents, I think you mentioned, could they verify what they're doing and then learn from it as well? Is that part of the loop?
Yeah, I would say, that you nailed the two main things. Is one, ability to act in the real world, and second is ability to verify things. And normally they would verify things by actually trying to act and then seeing the result of this action. So with software, I think that's the sweet spot there. But also sometimes, let's say, sometimes it's easier to verify the solution than to find it. Let's say, maybe in math, okay, if you know like if you know math well enough, you would be able to try to follow the proof and see if the proof is correct, but then coming up with a proof is much harder. And so I think like LLMs exceeding in also like competitive math is also like something where they can actually, once they reach the certain level of quality, when they can actually themselves verify their solutions, then they tend to get a lot better. And also you, like regarding the learning bit, that's actually a really interesting aspect, because the agent, in the core of the agent is an LLM and a large language model, which is like frozen. It's not learning, but the learning in a sense happens through its context. So kind of the model operates on some context, like what it has produced so far in your conversation. And like it can figure out some things in the context and then use these things which are in the context to do better continuing this conversation. But then there is the other aspect of like when actually people train these models with reinforcement learning. So for example, like all the recent reasoning models, they would be trained to actually try to execute things and see results of these actions and improve the actual model based on that, so that the model is going to be better next time executing these actions.
Yeah, makes sense. Yeah. So where does the world of data extraction and web scraping fit into this then? Because I can kind of see it in two places. I can see it as a source of data for your agent to use to return the answers to whatever you need or do the task for you, but also to train it up as well.
Yeah, that's true. I think that's kind of how like web data extraction can help the agents. And so, for example, like with ChatGPT, I think one of the like really major quality of life improvements appeared when they integrated search, and when actually you're asking about something and it can look things up and read the web pages. And so for that, you kind of want some API which returns you search results. So for example, in Zeit API, it's like SERP, called SERP API, and then there are like other alternatives out there as well. And just also being able to access any page. Again, you kind of don't want to be stuck on like Cloudflare blocking you and so on.
Yeah, it's always that age-old problem of being able to access the data that you actually need to be able to sort of move on with the tasks.
And sorry to jump on a complete tangent, but like we were recently with the team reviewing the like OpenAI agent release, which is like a browser, an agent which can use a computer and like primarily the browser, but also other things like spreadsheets and so on. And so we saw that it actually does suffer a lot from bans. So just like for a lot of websites, it can just not access them because it's getting banned by various anti-bots.
Yeah, I guess it just uses kind of like just a standard browser automation to try and load up sites.
Yeah. So probably I think they're using some maybe like remote browser, and they're not so like sophisticated as like some companies who specialize in that, and so
yeah. I feel like this point gets missed quite a lot, especially when I've been looking in and talking in circles about agents and the whole kind of like use your agent to scrape any site type of like promise. That the whole like actual extracting of the data, as in getting it from the site, does seem to get neglected quite a bit, and it is a massive part of it. So I guess it's natural that a lot of companies like Zeit are kind of jumping on getting these tools integrated in.
Yeah, and I think here like this is about like, okay, can we use the agents to do the web scraping for us? And I think here like you can like maybe consider two major approaches. Like one approach would be the agent actually doing stuff for you. So for example, like this OpenAI agent, it would actually open the browser and like read some pages and look for something. So for example, if you're looking for a specific like product across multiple websites, then like the data point you care about is like, maybe just one data point. And in this case, this approach kind of makes sense and it imitates like what a human would do. But then for a lot of companies, they don't need like a single data point. They need like millions or more like of data points. So maybe they want to, I don't know, crawl all sports newspapers in the UK or something. And obviously here you don't want the LLM to just go to every page and analyze it separately, because that would be like very inefficient, take a lot of time. So here you kind of want to have some to write some code which does that. But you can like ask the agents, so the agents are really good at like software development and getting better and better. So the natural thing is, okay, ask the agent to write the code for you, which would do that.
Let's expand on that a little bit then, because I think I've had a lot of mixed experiences with using the agents and LLMs to try and do development for me. Do you feel like it's probably in the best place that it's been, but how is it kind of at the moment for actual production code?
Yeah, so I would say let's first talk about software development in general. I think agents are definitely getting there. Especially, I think it also depends. I think what I've seen on Twitter is like a very like mixed perception of the agents and usefulness, and I think it's partly like due to like people having different mindset, but also I think it's partly people having different level of expertise. So for example, if this is like, let's say if you are like an expert developer and this is like your core expertise, and then you are like very likely to be like faster and better than the agent. But then so people like that, maybe they are like very skeptical of that. But then let's say you need to develop something where you are not like exactly the expert, so you're like slightly stepping out of your comfort zone. And then here agents suddenly become like, yeah, people can build like working, I don't know, iOS apps if they just have some software development background but never build an iOS app. And this is, I think, quite powerful. But I think you still kind of need to have overall like understanding of how software works. So I think like they're still not at the level where you can completely like be hands off. But I think in my personal experience, I would say I kind of tend to use the agents in two cases. So one is when I understand something is maybe not something I do normally. Let's say I normally do like machine learning in Python, and then for example I need to do like some a bit more complex UI in like an Angular, which is again something which I'm not too familiar with as being more used to React. And so there like the agent is really helpful, and I can like test the changes visually and I can kind of guide it to the right direction more or less, but I wouldn't be able to produce the same. So they're really helpful. And the other case where I find them helpful is when you kind of have something which is maybe not exactly like super high priority, super critical, but you can just give it a spin, see if the agent is able to come up with something good. If good, yes, that's good. If not, okay, you either do it yourself later or just don't do it.
I guess if you've got good test coverage already that you can use to look at it, or whether I suppose in cases where you want to just get like an MVP up really quickly. I mean, for me, from my experience was probably in the first camp that you talked about, because I think I have sort of relatively deep knowledge on one specific subject when it comes to this. So like, I think I was probably expecting too much of an outcome from something like that. Whereas if I was to, as you say, step out of that and start to work on something slightly different, I think it'd be very beneficial. But I guess I still see it as very much a supplementary tool. Is that kind of where you're at as well?
Yeah, I would say so. So I mean, you definitely need to review the results and not only like test them, but also like review the code and so on. And like also like sometimes it can do like the tasks almost end to end, but in my experience that's kind of the exception. And so I think ideally you should it's nice when you kind of understand how the task can be broken down into smaller pieces and ask it to do smaller pieces.
So for a web scraping point of view then, what's kind of like the ideal scenario, do you think, for a lot of businesses for their agents?
Yeah, so I think the web scraping is like really tricky for agents. And that is, I think, because like the context management becomes really tricky there. So if you just, let's say, take like an really like basically one of the state-of-the-art agents, let's say like Codex from OpenAI or like Claude Code, and ask them to do like a typical web development task, let's say like extracting data from some website, and we're not even talking about doing the whole task, just like a small, very small piece of the task, which would be, let's say you have like a product page and you want to write some code which would extract product attributes from a product page. So, and to do this task successfully, like a developer, like a scripting engineer, they would look at the page and figure out, okay, where is each piece of data contained in this page and how to best extract it. So, for example, they could see, okay, the price is located in that element, and I need to like maybe write like a certain like expression like XPath or CSS expression, which basically locates this element within a tree, and then do a bit of post-processing. Or maybe they figure out, okay, no, actually, I would rather call like an API or simulate an Ajax call, or maybe this is already like available in some JSON snippet on the page. But the problem here is that like web pages are really big. So like the web page HTML is like can be, I don't know, like up to like 1 million tokens. Like it's usually like in hundreds of thousands of tokens. And like if you just put the whole HTML document into the context of an LLM, then it would run out of context very quickly, because even with the best models, it's limited to like 1 million tokens of context. And so you can't really put the whole document there, but also like so the approach these agents use instead is to just read stuff in little chunks. And so what it would do, it would maybe read the first 100 lines of the file, but then it's kind of a bit lost. So what it would do is it would, for example, this Codex agent, and it would try to just let's say it wants to extract the price, and it would try randomly like searching this document for some random things, like searching for price, searching for, I don't know, costs, searching for certain expressions, and basically try to do a bit of a guesswork, because it doesn't have like perception of the whole document, and it can't have the perception of the whole document because like with the way this like context management normally works with these models, if you try to read it the whole, you will like kind of forget everything you knew before and forget what you were doing. So I think basically what I saw is that while they can like work quite well in some cases and in simple cases, but actually they do need some specialized tooling to work well. And I think we're just like doing a bit of research in that area as well. And like we experimented with various things. Like we experimented, for example, like radically simplifying the HTML to make it much smaller, but preserve still like the main information there. And that tends like to work quite well. But so far we're using not exactly an agentic approach, but rather like a basically hard-coded workflow, how we orchestrate like multiple LLMs code to generate extraction code and manage the context well. So basically it's a bit similar to how you would code something in, maybe in the old days, code something in assembly, where you're like explicitly managing okay, which bits of context you send, and being really efficient and squeezing the most out of the model. But then with the agent you don't need to think about all of this, but then the quality might be not quite there without some specialized tools, which I think the industry as a whole is yet to figure out what kind of tools. Like grep is not the right tool to work with HTMLs.
No, definitely not. It was interesting you mentioned the size of the HTML pages, the like millions of tokens and the context. Is this where the LLMs start to hallucinate then, because they lose the idea of the context, so they aren't able to look back and see what's happened already?
There are a few things going on there. So one thing is that, like, let's say most models the quality would degrade as the context grows bigger. So even when everything still fits within the limits of the model, but then a lot of models would just produce worse quality results when they have a lot of information. Like let's say Gemini models are a lot better in that, and they support longer context. So I think Google has probably figured out something interesting which other labs has not in that regard. So that's one problem. And the second problem is when the actual context while working on the task becomes bigger than the limit. And I think this is like a very important part of these generic agents is what do they do when this happens. And I think like one of the strategies they're using is like context compaction. So it's a bit an interesting thing where basically, okay, the context now starting to exceed the limit, and they have some process by which they decide which bits of context to leave and which to throw away. So ideally what you want is, you definitely want the original description from the user about what we actually want to achieve to be still in context. And you want some key steps we have done so far to be in context and key findings. But at the same time, maybe the model read a big file and it turned to be like a dead end, or maybe it worked through some trying to resolve some test failure for 10 minutes and has a lot of tracebacks which are now irrelevant because the thing is fixed. So you don't want to preserve that, you want kind of to forget that. But this is still, I think, so this is not native to the model. So this is something which is done by some external bit of code which manages the context for the models. And and that's bound to be not quite perfect and not quite working in many cases. And actually, I think people who are really practically working with this agent day in and day out, I think they often recommend, okay, just when when you reach the limit, just start fresh. Just again, start the new session and just tell the model, okay, model, now we're here. This is what is left to do. This is, what is happening. And again, this is more manual management of the context.
Yeah, well, it certainly sounds like there's a lot of problems still to overcome. Not just, especially with the data extraction and the web scraping side of things. Yeah. I guess what's the ideal solution then? I guess from my point of view, it's you use your agents to call an external service, which is obviously what we do at Zeit. I think that probably has to be the right solution for getting your agent's data then.
Yeah. So I think what we're following so far is kind of letting the agent handle the general software development part, but handing over the parts which needs to interact with HTMLs to an external MCP server, which can then use LLM calls, but which won't pollute the context of the actual core agent. And in this way, you still have relatively modest small context of the main agent, and then use specialized tools which handle, for example, figure out, okay, the first step is which data should we extract from this page. Then second, okay, which selectors do we want to use? What kind of code snippets do we want to use? And then fixing any test failures. But there you can also have a slider between a more hard-coded approach and a more generic and agentic approach. And what we're doing right now is we're starting with a more hard-coded approach, and our goal, foremost goal, is to have good quality. We want the users to be happy with the quality, and so we want to achieve that, and then over time to make it more agentic, but keeping good quality, and making it more agentic. The reason to do this is I think twofold. Is one is to simplify the system, so simplify the implementation, and second is make it more flexible so that it can actually do more things in terms of, let's say, using more extraction strategies. For example, not just getting data from the page, but also figuring out, okay, we can make some AJAX call, or maybe we can run a headless browser and capture the network requests we're making, and based on that, figure out how should we better be getting the data.
one of the bigger problems that I think a lot of people that come across when they start web scraping, and I think this is probably going to apply here, is how to scale that up. How do you end up? How can you scale up your agents in a way that it would still keep that context and it would still be able to work for the process? Because if you're just like you're making a few calls to websites to gather some data and then process it in some way, that's very well and good, but we know that that's not always the case. In fact, it's usually tens of thousands or hundreds of thousands of pages in one go. How do agents manage to cope with that amount of data? Is it just running in parallel, or is it more a complicated architecture solution required?
Yeah. I think there are like a few scale aspects here, and like one scale aspect is just the number of data points we have. And here, like this one is like relatively straightforward if you write the code. So when you just write the code, then running this code is typically very cheap because you're not using the LLM while running the code ideally. Or if you are using an LLM, so in some cases you still might want to, for example, you might have like a product description, which is like some like human written description. And from that you want to figure out, okay, what colors does this product have, what materials, in case they're not explicitly mentioned. Then you might still use an LLM to do this bit of work, but then you can use just send it just this description as the context and use a small LLM. We have like these mini nano models and so on, which are like super cheap, and so you can actually afford to run them over millions of samples quite easily. But then I think there are a few other aspects of scale which we need to solve. Like one is, let's say, the number of websites, because at least at Zeit, a lot of projects have like tens or hundreds of websites in them. And for a lot of customers, they don't just need data from one website, they need data from across a whole range of websites, but which still follows the same schema so that they can eventually just compile it into one big data set they gain insights from. And in that case, if you can just, go one by one. So you have one website, you ask the agent, hey, my little agent, do this website for me, and then verify that it works, and then do another website. This obviously works, but this can be quite slow, especially as agents get better. So for example, if the agent gives something reasonable in, 90% of the cases, then you would be better off automating this part. And then I think we enter another, important distinction between different agents is whether they are local or whether they are remote. A local agent would be an agent which is running in your editor, in your IDE, and running also the code locally as well. So whenever the agent tests something, it would run the code on your machine and will fix bugs based on that. But then the remote agent would be something which you control either through the browser or through some API where you can tell, hey, the agent, this is the source code I'm working on. So you would typically tell it, okay, this is the GitHub repository I'm going to work on. Here is the environment I need to, because the agent would actually need to run any tests it needs to run on their side, on the remotely, in the cloud. And then then such agent, you can actually, if you have 100 websites, you can just give this agent 100 tasks, and it will be working on them in parallel, and that can speed things up a lot. I think we're not quite there yet. So first, I don't think there is any remote agent which works well with web scraping tasks, and second, I think the quality really needs to be up there for this approach to make sense, because if you need to fix everything manually anyways, then you might just as well run a local agent, because it has its advantages. With a local agent, you can you have a lot less latency, you can step in much easier, because with remote agent you cannot, usually the artifact it produces is some pull request, and ideally you don't want to be babysitting a remote agent. So ideally you just give it some tasks or give it multiple tasks, and when it's done, it just tells you, hey, I have finished, here is the PR, or hey, I have finished, but I kind of got stuck and don't know what to do. Please tell me how to to get out of this, or it just completely failed, then you're better off throwing away this work and starting from scratch.
Yeah, start all over again.
Yeah.
How does that affect the costs then between the local and the remote, and then scaling up? Because I guess the more data that you throw into the LLM via your agent or whatever the costs are gonna ramp up quite quickly. I'm interested if you think there's like a crossover point where having it done fully in an agent versus then having it pull externally is viable.
Yeah, I would say, I think the main cost center here is the LLM calls, and they remain the same whether you are using like a local or a remote agent. Like probably realistically the local agent would be normally more efficient because you are going to babysit it a lot more. You would be also can have more control over which context it receives. You can intervene if it's gone off ramp much quicker. So realistically, the local agent would be cheaper even in terms of LLM calls, and then obviously you don't have to pay for the cloud environment. And yeah, this like LLM costs, like I think like add up quickly, and I think also a lot of companies, I think they are not really pricing their products let's say so they're basically discounting the usage a lot. And like I think it's quite famous that a lot of like leading companies which provide ID agents, they actually sell LLMs at a big loss for them, and like which helps them to grow the user base, because the user has a choice. Okay, do I pay OpenAI API, or do I buy a subscription from from some company which provides the agent? And subscription is maybe like $30, and the API cost would be like $300. And obviously you would prefer to pay less, but then eventually they need to start making money. So I think it's like the companies which provide the actual infrastructure, like OpenAI and Anthropic, they are making, like, ignoring research costs, they are making profit, and I think they can afford to ignore research costs, right, with the funding they receive. But I think a lot of like companies which provide products downstream of that, they are not making profits. So yeah, the costs end up, and it would probably become worse as the industry matures and like people actually start making profit.
Yeah, of the ones that are available, and we've mentioned a few different of the tools. Is there one that's kind of like stands out for software development more than the other? Because I mean, the last thing you want to do is have to pay for various different ones and then try and split tasks over them.
Yeah. I would say, to me, there is no clear winner there, and I think but I think people are like really passionate about the tools they choose. Like people who do use them frequently, they're really, I think, passionate and opinionated, and I think
that
there
happens
are
in everything, doesn't it?
Yeah, right. Yes, and I think like there are like a few like, I don't know, favorites there, like in terms of love of the people. So I think like until recently, like Claude models were like widely regarded as like the more like reliable and like suitable for agentic work, I would say. And then I think also like the implementation of the agent matters a lot. For example, again, people, let's say there is like Cursor and Copilot, which are kind of like GitHub Copilot, which are kind of comparable things, and they can use the same underlying models. But then people would often cite that, and then also like Claude Code, which is like, or Codex, and people would often cite that actually like agents made by the companies who produce the models tend to kind of work better with this model. So for example, like Claude Code tends to work better with Claude models compared to just generic like GitHub Copilot agent. And same, like also Codex with OpenAI tends to work a bit better there. But I think there is no clear winner, and with the releases happening, like there is, the GPT-5 is like, clearly like a really good model. Maybe it's not as good as some people hold, but it's like really clearly very, very good. And then also like the Gemini models, and like with upcoming Gemini 3 release, which is probably going to be next state-of-the-art model, there is always no winner, I would say.
Yeah, it's definitely a fast-moving industry. There always seems to be something new coming out, and there's always a lot of hype around it, which I guess works for a lot of people. But I find it quite difficult to sort of manage or try and stay on top of. But it's fascinating. I think what I'd like to talk about a little bit now is a little bit about how you feel about, and have you used any of like the big automation tools where your agents kind of fit in, and like the whole using agents to replace people, I suppose.
Mm-hmm.
I'd be interested to know what you think about that, having done lots of research on the topic recently, and how you feel that kind of is progressing through the industry.
Yeah, I think I would say I have personally not seen any areas where you can like just literally replace a human by an agent, but I have seen impact on people, definitely. I probably think that there probably would be some areas, but I think at the end of the day, like you cannot hold like an agent accountable for something. Some people try, and I think there are some funny stories on Twitter about that. But in the end of the day, like the human is accountable, and but often like the agents allow people to do more work, or LLMs in general. And then I think it depends on the nature of your business. Like if you have like a fixed amount of work you can do, and you are becoming more effective, then maybe the business would want to fire someone. But then as a business, if you kind of being able to do more work allows you to earn more money, then you don't want to fire anyone. You just want to do more ambitious projects and to do more with the agents. And like one of the aspects personally where I've seen LLMs affecting like actual people was like with like the annotation vendors. Like I think some companies hire like people to annotate the data for them, and I think there with LLMs often you end up needing less of that work, because like with, let's say, old school models, you would need like thousands or like tens of thousands of data points or more to like fine tune the model on your data set. Whereas with LLMs, you're typically happy with a much smaller data set just to evaluate the quality, and you'd rather invest like, time into making sure that the data set you're evaluating on is absolutely top notch. And also you have a lot more of these data sets because you're kind of solving the task faster. So instead of like taking maybe like a month for fine tune some model on a new task, you now spend like maybe half a day to write a prompt and then make sure that it works well. And you end up like maybe needing less of that like bulk annotation work, and more of like specialized and very domain specific and always changing annotation work.
I don't know whether I'm naive in this area or not, but my perception is just, that I don't feel like it's going to make a massive dent on replacing people. Like all everyone puts out on the internet, they're doomsaying about everyone's jobs going. I just can't see that happening. Even in software, with the progression and you've still got to have somebody that's going to have to understand what's going on within there. And that just totally ties back into our industry in web scraping, is that if you don't have that knowledge of how it works, and obviously this is the same for everybody else's sort of specifics, if you don't have that knowledge of it, you're just going to end up going round and round in circles with the worst code ever that you're never going to get anywhere with. And obviously it just tries to fix itself and fix itself and fix itself, and it just doesn't get anywhere. Totally. I think like there is definitely impact, but I think it's not the impact in terms of replacing people. It's more impact in terms of different skills become more important. And so I know that we are in company working on a lot of things regarding this, without giving away too much, I suppose, until we're ready to talk about it properly. Where is the future going in web scraping specifically using AI and agents, do you think?
I think we can talk about some things really. So one thing is, let's say at Zeit we have like, I think through evolution of our products, you can kind of trace the evolution of industry too. We're doing like both projects and one also like producing tools for people to extract the data, and people have different levels of expectations in terms of quality, which is kind of important when we're thinking about agents. And let's say there are people who like really want absolute highest quality, and for them it's extremely important that they're willing to pay extra to make sure that the quality is absolutely top notch. And for these people, like both like machine learning and then maybe even heavy usage of agents is not always beneficial, like especially with a machine learning model which might extract data by trying to predict to extract the data on every page. Like for such people, for in these use cases, they might not be happy with the quality of the model. And then for cases where like the quality of the code needs to be like really top notch, then again it might be better to just write the code from scratch than to to babysit the agent to really reach that desired level of quality. But then in a lot of cases, people like don't mind maybe an occasional mistake, and actually a lot of cases people would rather get more data of slightly worse quality than like less data of absolutely highest quality. And like there are many cases like that. And in these cases, both machine learning models in the past and then especially with the like LLM-based approaches now, we found them really, really useful and being able to do the projects better and quicker. And with LLMs, which generate the code, they allow this autonomy slider in terms of you can either do the task like fully autonomously. You can just, we've built like a system where you can tell it, here is like a few like example URLs, please write me, and here is the schema, please write me the extractor which would cover that, and it would do it end to end with like really high quality. But then if you want to like raise the quality a bit of extra, then you actually have controls over that. So you can either tell it, hey, you made a mistake here, please fix that, or you can actually go and fix the code yourself. And this is actually a really seamless experience where you're working with the same system, but you can decide on what is like the granularity, and you can efficiently step in. And I think like building products and tools like that is like really it allows like to use these agents in different situations, in different quality requirements, and also like smooth over the rough edges when the tools are not quite perfect.
Yeah, absolutely. Using the right tool for the right job in the right situation is everything, I think. So I know we've covered quite a lot in this conversation. Is there anything else on this subject that you wanted to mention or talk about, or anything that we haven't covered?
I think maybe one aspect I had in mind was about the UIs and like let's say how we interact with agents, because the canonical way of interacting with the agent is like through chat. So we just write some prompt and we explain what do we want to do, and then the agent does something. And if it's like primarily a software agent, then normally the output of the agent is some change in your repository. And like this is okay for developers, but even for developers this is actually far from ideal. And so ideally, again, this is like where we're going into more specialized use cases like web scraping. So let's say if I'm working with an agent for web scraping, ideally I want to be able to look at the code, but this probably shouldn't be the main representation. So ideally what I want to look is I want to very quickly verify, okay, is the data being actually extracted correctly? What is the strategy it chose? Like what kind of like strategy to follow the website did it choose, and can I affect that, and what is the quality, and can I look at the sample of the data quickly? And so really I think as the industry matures, I think we will see more like specialized UIs for the agents, which are not just text-based, but which provide like richer controls, which are domain specific and which make people much more efficient when working with the agent. So this is like a change which I haven't, like, to be honest, I haven't seen that much when it's applied to software agents. So I would say there is like a class of products which are just okay. They even if they have some code, they completely hide it. Or they are like pure coding agents where you don't have any UI besides the code. But I haven't really seen this mix, and I think exploring this like mixed UIs is like really interesting.
Yeah, that is interesting. It's not something that I considered really. I'd always just sort of defaulted to you deal with it through natural language and a chat prompt.
Yeah,
it's interesting.
Yeah.
Super.
That's
cool.
I think all I had in mind.
Brilliant. No, this is it's been really, really interesting, and I feel like I've picked up quite a lot of information and learned a lot from this. So I really appreciate your time. Thank you very much for talking to me, and thank you.
Yeah, thanks a lot, and nice talking to you.